thanks for the Kiran Kumar for accommodating in the last minute. This is supposed to be a 1 hour longer presentation, so we compressed it into 10 minutes. I hope I can convey the point in 10 minutes. I'm Venkatesan Murugesan. I have Lax, my colleague, with me. We both work for Intuit. Today we are going to be talking about breaking a monolith UI into micro frontends. How many of you work for a product that's more than 5 years, or code base that's more than 5 years? Okay, that's good. More than 10 years? 15 years? Okay, that's good. So even if you're not working on such a big monolithic code base, you will find it useful because it's very important you understand how to break the big code base into smaller modules. And with that, so this is one of our popular product in US. It's called QuickBooks, and it's a financial accounting software where you can create invoice, receive payments, and at the end of the year you can file taxes. So this is the very first screen, and similar to this we have like maybe 50 or 60 screens for the entire product. And 5 years ago or 4 years ago, our code base was like this on the leftmost side. One big giant Java code base with a JSP, Dojo, and everything. When the code is getting older, people dump more code into the single code base, single repo, and it becomes like a giant monolith. And that's the state. That was the state 5 years ago. And we were releasing once a month at the time, and a lot of war rooms. We spent like 2 days continuously debugging if any bug goes into production. And then sometime it takes like 2 months to release the next version. So that was a tipping point. So we wanted to break the code base into first into the front end and the back end. And we were able to do that in 4 months. And that gave more light to us more incentive to us to break even further. So this is the key important aspect when you're designing from the ground up, or you are taking your existing code base into the future. You want to break it into meaningful chunk so that independent teams can release faster. So here you can see that the back end, we are in the process of breaking it further, but the front end is completely broken into a concept called plugin. Plugin is nothing but a collection of widget. A widget is nothing but a React component. Okay? The beauty of breaking that into plugin is we built entire automation around the plugins, so that any engineer commits a code, it goes to production in less than 10 minutes. So you can have multiple Scrum teams. We have about more than 500 or 600 engineers at Intuit, and there are like 80 plus Scrum teams. Each one of them are like 5, 6 engineers. And we want every team to commit code, and that goes to product as fast as possible. So this architecture enabled us to achieve that. So let's go a little deeper into that. And this is how it looks under the hood. Left side of that line is the browser side, and there's a server side front end aspect. We call it a shell side. You may see a lot of acronyms here, App Fabric, and those are our internal code names. Don't worry about that for now. Focus on the architectural components. So there is a big piece called shell, which is a container that abstracts all the common aspect of your application. Like for example, the React library is common aspect, and then logging, tracking, and all the things that every feature wants to do, those are abstracted into the shell. And the leftmost side, you see the plugins. That's where every feature, the individual feature teams, they can build the plugins and they can independently deploy. And that consists of widgets, which are basically a React component. And the shell service side, basically what it does is it creates the very first page of your application. It's basically spits out the single page application, the HTML, and on the client side, the shell bootstraps, and then it starts rendering your plugins. Okay? And we can go even further deep into the shell itself. So this is how a plugin works within a shell. There's a concept called sandbox object, and it can communicate to the parent shell if it needs some common aspect, like which OS you're running, which kind of browser you're running, and whether you want to send a logging back to your backend. And instead of every plugin duplicating the same logic over and over again, we abstracted all the things in the core shell. And it can also on-demand load the runtime, any library that are not required upfront. So that optimizes for performance as well. And there are pieces like app plugin that gets some priority over when it should be loaded, and you can customize your app plugin to load the toolbar on the left now, because those are the first thing you wanted to load. Okay. I know there are a lot of things here. We ideally would like to host another meetup at Intuit location. We'll go deep into every detail of this. But the key takeaway you want to take from this is like, make sure from the day one, modularize your code so that the next person coming, they don't end up worrying about who else they're going to break. Okay? And with that kind of architecture, we were like, during May 5th, I think 2015 May, we were releasing 2 times approximately per month. And then you can see that at the end of January 17, we were like 245 releases, like in a month, basically. So this is a kind of a outcome we achieved by fully automating all those release and deploy mechanism. And our entire tech stack looks like this. Maybe you can speak a little more. And we do have open source components. Lax will talk a little more on that.
I can start. I can take this.
Yeah. Yeah.
This is our entire tech stack. Of course, the front-end part we talk about it, but behind the scenes there are a lot more things. We work heavily on Kubernetes, and there are around 500 services today, or 1600 services on Flink model, 500 services today. But at every place we try to break it into a smaller component or smaller chunk, so it becomes much easier to manage it. Right? So we use, of course, the AWS platform to host the Kubernetes service. On top of it, you have either we do it in a Spring Boot or Node.js, CloudFront, for any of the AWS services that we need. And then, of course, these are a bunch of other internal tools that we use, app dynamics and other things. And there are a few other things.
Thanks, Lax. So this entire infrastructure is automated in a way that if you join Intuit and you create your first application, this is automatically taken care for you. So I'm going to show a video that's going to showcase how you would create your application in less than 10 minutes just by clicking and entering few critical information. Hopefully Wi-Fi works. Okay, good. So this is our developer portal, and a new developer can come in and create a new plugin. They can punch in the name, and we have multiple teams, so they select which team they belong to. We use that information to organize the Git repo, because the source code should be organized per BU so that we know the ownership of that. And just type in some description, and you can choose whatever icon you want. And this is another, we break our code base into capability. Like if a central team is providing a credit card widget, we don't want every other team duplicating it. For that reason, we bucket them in the right place. So you can see that we entered few information and then click a plugin. And behind the scene, it goes and it generates a skeleton code for you. And then it creates a Jenkins job, which can package that code. And it also uploads to the appropriate AWS account. And then and it's going to see that's a code, generated code. And the beauty of that code is like all the unit tests and integration test frameworks are automatically generated for you. So you just go and write your business logic and additional tests. You don't need to worry about infrastructure at all. So that's a standard React code. And within like few seconds, it's going to show the output, and your code is live. It's still building. And we use Jenkins Blue Ocean pipeline for automating the entire flow. It takes care of running the automation tests for you as well. So if every team has to do all these things, that will take forever. So that's especially if you're working application in a large scale. You don't want every engineering team to be repeating all this stuff. So you can see.
As a developer, we
Yeah.
want you to focus on developing the feature
Yeah.
as opposed to working something on the platform and security. Those things are taken care automatically.
Yeah.
There is a team behind the scene which works on it.
Right.
But as a developer, you
Yeah, this, sorry to interrupt. So this is the part that you can see the last section appeared, and it created a URL for you, and your code is now live. And when you click on it, your very first application is live in production. So, and if you come in as a new engineer, that's the power of like your first code when it runs and you see the output, you cannot like that's the joy, right? So it actually goes to even production, not even in your machine. So that's the kind of automation we built. Maybe I'll pause here and I'll wait for any question. Good. No question. Maybe one.